Okay, so by putting all of the code for merging two sorted lists into one in a separate function, that's made the remaining merge sort algorithm a lot easier to follow, and all of the detail of the merge part has been abstracted away. So now we can see how the full merge sort algorithm works. As you can see, there is one parameter, which is my list, which is the list we're passing in for sorting. I'm using a short list for demonstration. High is our way of identifying the last index, which is the length of the list subtract 1. So the length of the list here is 4, subtract 1 is 3. So it's 0, 1, 2, 3 is the last index. Mid is going to be the last index of the left hand side of the list. So it's in this case 3 divided by 2 is 1.5, and the integer part of that is 1. So the left hand side of the list is going to be 0 and 1. Now if the length of the list is greater than 1, it needs to be sorted, otherwise it is returned, because if the list has only got one element, it's already sorted. Now in this case the length of the list is greater than 1, so we'll go to sort it. The first thing that happens is that the left list is defined, which is my list 0 to mid or 0 to 1. So that is the left list, and the right hand side is defined as mid plus 1, which is 2, to high, which is 3. So indices 2 to 3 are in the right hand side. Now the left hand list is then passed to the merge sort algorithm. Well, this is the merge sort algorithm. Now when you call a function from within itself, this is known as recursion, and the more it calls itself, the deeper it goes. We're going into deeper and deeper levels of recursion. So it's a little bit hard to follow, but by using these little paper squares here, it should be a bit easier. So we're going to send the left hand list off to the merge sort algorithm. So I'm going to show it being sent off, if you like, by bringing it down a level, and we can now see what will happen. So now my list has now only got 2 elements. We identify the lowest and the highest. We have the highest element and the mid element. Now the mid element in this case will be 0. Is the length of the list greater than 1? Yes, it is. So it still needs sorting. So the left hand list will be my list 0 to 0, which is this one. So that's the left hand list, and the right hand list will be 1 to 1, which is that. The left hand list is then sent off for sorting. So I'm going to move that down to show that it's been sent off for sorting. Right, so let's go back to here. My list has now got 1 element, and it's going to be from 0, and the midpoint will be 0. Is the length of the list greater than 1? No, because it's just 1. So it doesn't need any more sorting. So we return my list. So now this is returned back here, but this is now sorted. Okay, now where this was called from is where we return. Now it was called from here, merge sort left. So we now do merge sort right. So this list goes off to be sorted. Is it greater than 1? No, so it gets returned because it's now sorted. So we've now sorted the left and right hand sides, and we've returned. So now we do this, which is merge the left and the right. So we can now merge these. So we send them off for merging. Compare the first 2 elements, 4 and 3. 3 is the lowest. 4 is then appended to the list, and then these are returned from the merge back as a sorted list, and then this is actually then returned back to where it was called, which was actually within the first recursion through the merge sort. So it gets returned back to here when the original left hand side of the list was called. We now do the right hand side of the list. This gets sent off for sorting, so it gets split, and each of these then gets sent off for sorting. It's only got one element, so it's returned as a sorted list. Then we do the right hand side, that gets sent off, is returned as a sorted list. These two lists are then sent off for merging, and they are merged and returned from the merge function as a sorted list, and then this then returns back to the where it was called, which was merge sort right. So back at this high level, we now merge the left and right hand lists, so they get sent off to the merge algorithm. The merge algorithm compares the first two and selects the one, compares to the first two and selects the two, then appends any remaining elements to the list, and then returns that back to the calling function. This is then returned actually as the result of the merge sort algorithm. Okay, so recursion is a little bit confusing. They say to iterate is human, but to recurse is divine. So it really is the highest level of algorithms, and if you can at least follow it, then that really is that is kind of the pinnacle of understanding algorithms. So the key things to identify are that the length of the list needs to be greater than 1 to actually continue in the merge sort algorithm, and once the list is broken down into single elements, then we won't call merge sorts anymore, and it will just do the next stage, which is just doing the merging. The other thing to realize is that we do the sort the left hand sides before the right hand sides, so that's interesting. And so you would see the order things are done are slightly different than we might have shown them on paper. So you don't really need to know that for GCSE, but I just think you need to be aware that when we're showing our sorting on a piece of paper, we're actually trying to reflect what is really happening within an algorithm. So it's important to see the relationship between the two.